Why American F-22 Raptor and F-35 fighters are so stealthy. Introduction. Low visibility is desirable for all military aircraft and is essential for stealth, such as visual stealth, infrared stealth, acoustic stealth, radar stealth, and stealth flying. Definition of stealth technology. Stealth technology is not about an aircraft, but designs, materials engineered and manufacturing techniques for the military purpose of avoiding detection by radar or any other electronic system. Stealth or anti-detection technology can be applied to tanks, missiles, warships, and aircraft to make the object more difficult to detect at closer and closer ranges. How stealth works. There are two different ways to create invisibility. The aircraft can be shaped so that any radar signals it reflects are reflected away from the radar equipment. The U.S. Air Force F-117A stealth fighter, now retired, and B-2 bomber, were a low profile with no flat surfaces to reflect radar directly back, the intensive substitution of radar opaque composites in place of metals, and an overall coating of radar-absorbing material. Microwave curing. American Lockheed Martin and Northrop Grumman pioneered microwave curing of composites. Microwave curing of composites can offer substantial reductions in the time and energy required to manufacture carbon fiber reinforced plastics, CFRP. This improvement in processing times and the energy consumption is derived from a composite material's ability to absorb electromagnetic volumetrically, EM, energy within the gigahertz region. Machining, baked-in and molding technology. The F-35 airframe is composite, not metallic. The naked skin of the F-35 is very stealthy without regard to any externally applied coatings. The F-35's skin comprises a sophisticated cyclobismulimide resin and very proprietary geometric laminations of carbon nanotube mat. The skin itself has different RCS mitigation capabilities at different depths and orientations of the mat and resin. It must resist flex, twist, thermal expansion and contraction, retain shape and stability under very high polyaxial physical loads, as well as retain those properties for several decades in the full spectrum of global environmental conditions. The F-35 has a small opening that uses air traveling past the aircraft to cool down the fuel inside the aircraft. This is important because the F-35 uses fuel to cool many aircraft systems, including the exhaust nozzle, to make it less detectable on infrared. Things like the radar can use more power without overheating. The F-35's skin is highly effective at mitigating X-band and upper S-band radars, and having a useful degree of mitigation versus VHF frequency radars. Final steps. Once the composite skins are molded, trimmed and inspected, they are ready for attachment to constituent airframe structures. On the contrary, Russian and Chinese aircraft's airframe is metallic mainly, and the fuselage structure is accomplished with fasteners drilled through the skin and into the frame at predetermined locations. Hence Sukhoi Su-75, Su-57, Chengdu J-20 and Shenyang FC-31 have screws and drill holes. Thanks to poor quality, screws are exposed to heat and weather conditions detrimental to the integrity of the aircraft's airframe. Thermal management. Thermal management will be a critical factor to maintain radar-absorbent material. The rectangular air intakes on both sides of the fuselage are covered by gratings coated with radar-absorbent material. The vast and flat structure of the engine exhaust area reduces the infrared and radar detectability of the aft section of the engine. The two large tail fins slant slightly outwards to provide an obstruction to the infrared and radar returns from the engine exhaust area. Thanks for watching. Follow us on Twitter, Facebook, YouTube, and Instagram.